Okay, imagine this for a second. You're driving through California's Central Valley, past all those fields, and then you see something kind of weird on a dairy farm. This is like this huge, like balloon-type tarp stretched over what you figure out must be a manure lagoon.
Hmm.
And it looks odd, sure, but it's actually a sign of this really significant change happening and turning a big environmental headache into, well, a climate solution.
Exactly. And that headache fundamentally is methane, a really potent greenhouse gas. We're talking, what, over 80 times more powerful than CO2 in the short term, like over 20 years?
Right. And a lot of California's methane comes from dairy cows. Not just, the burps everyone talks about, but really critically, how their manure is stored.
That's the key bit. When that manure sits in these big open ponds full of water, it breaks down without oxygen.
Anaerobically.
Anaerobically, yeah. And that specific process, it pumps methane straight into the atmosphere.
Okay, so that covered lagoon we imagined, that's the fix. That's the dairy digester.
That's it, a sealed system designed specifically to catch that methane and actually put it to use.
So our mission for this deep dive is really to unpack how well these things actually work in the real world.
Right, and we've got a brand new study to help us do that.
Yeah.
We want to look at the broader picture, too, for climate action. It shows how sometimes these, slightly unexpected innovations, even from a place like a dairy farm lagoon, can lead to real measurable benefits for everyone listening.
Okay, so let's dig into that methane problem on dairies a bit more. You said the key is that decomposition without oxygen.
Exactly. Those large, open, water-filled pits, they naturally create that oxygen-free or anaerobic zone. And that's like the perfect breeding ground for the specific microbes that churn out methane gas.
And the scale here, especially in California, it's pretty big.
Oh, it's huge. We have a massive dairy industry, a lot of it concentrated in the San Joaquin Valley, which is, hot and dry. Just to give you a sense, Tulare County, just one county down there, it produces more milk than any other single county in the whole U.S.
Wow. So that means just an incredible amount of manure to manage.
An immense amount. And historically, that meant a really substantial source of methane emissions just from storing it.
Okay, so how do these digesters actually step in? What's the tech? How do they stop that release?
Well, it's conceptually pretty straightforward. Instead of leaving the pits open, they install these gas-tight membranes or covers right over the manure lagoons.
Like putting a lid on it, basically.
Pretty much. A giant flexible lid. And that membrane traps the biogas, which is mostly methane, as it bubbles up from the manure. But then, crucially, it doesn't just sit there. It's captured, it gets cleaned up a bit.
Scrubbed, sort of.
Yeah, scrubbed, cleaned. And then it's often piped into fuel systems. A really common use, and a good one, is turning it into renewable natural gas to replace diesel fuel.
For trucks, maybe.
Yeah, exactly, for long-haul trucks. So you take this potent greenhouse gas, something you don't want in the air, and turn it into a cleaner-burning fuel, a renewable energy source.
Okay, that sounds, almost too good to be true on paper. Win-win.
Yeah.
But the big question is always, does it actually work like that in practice, out on a real farm?
Right, the real-world test. And that's where this new study comes in. It's a landmark piece of research, really. Came out of the University of California, Riverside, led by a climate scientist named Francesca Hopkins, published in Global Change Biology, Bioenergy.
Okay.
And it's so important because it's basically the first really thorough analysis confirming how well these digesters perform with actual on-the-ground measurements, not just estimates.
So how did they do it? How do you measure methane coming off a whole farm?
It's pretty clever, actually. They focused on one specific family-run dairy in Tulare County.
Yeah.
And get this, for a whole year before the farm installed its digester system back in 2021.
Okay.
And then for another full year after it was up and running, they collected just hundreds and hundreds of data points.
No.
They used this van, a van packed with really precise gas sensors. And they drove it around the farm, constantly taking mobile atmospheric measurements.
Like a methane sniffing van driving around.
Yeah, basically. Just quietly cruising, mapping out the methane levels around the dairy. Before and after.
And what did the methane sniffer find? What was the headline result?
The big finding was really compelling. The study showed these systems can cut methane emissions by about 80%.
80%.
Wow. And significantly, that number lines up really closely with the estimates California's already been using for its climate planning.
So it's like real-world proof that the models and the technology are actually delivering.
Exactly. It's powerful evidence that these things are doing what they're supposed to do.
But one thing I thought was really interesting about the study was that they didn't just report the good news, they talked about the imperfections too, right?
That's right. And that's crucial for understanding how these things work in reality. The study stated very clearly that digesters can leak, and they sometimes do.
So they're not magic bullets.
No, definitely not. It's complex technology operating in a challenging environment. Things can go wrong. And the UCR team, they actually found some initial leaks at the farm they were studying in Tulare County.
Okay, so what happened then? Did they just note it down?
No, and this is the really cool part, I think. They didn't just observe. They worked directly with the company that operates the digester, a company called California Bioenergy. They flagged the problems they were detecting with their measurements, pointed out where the leaks seemed to be.
Ah, so the science directly informed the operation.
Precisely. And based on that scientific feedback, the operator made adjustments, they tweaked the system, fixed the issues.
And the result?
The methane reductions followed. The system started performing much closer to its potential after those fixes.
That sounds like adaptive management, right? Learning and adjusting as you go.
Absolutely. Francesca Hopkins, the lead scientist, called it a textbook case of adaptive management. She really emphasized that partnership. You know, the scientist, the company operating the tech, and the farmer working together. She said it really made a huge difference.
That collaboration seems key, not just building it, but actively managing and improving it based on data.
It really does. It shows that you need that feedback loop to make these systems truly effective long term.
So zooming out a bit, this isn't just one experimental farm, right? How widespread are these digesters now?
No, it's definitely scaling up. There are already more than 130 of these digester systems operating on dairies across California.
Okay.
And it fits into the state's bigger climate goals. California is trying to cut its overall greenhouse gas emissions to 40% below 2013 levels by the end of this decade. That's 2030.
Ambitious goal.
Very. And for the dairies that can actually implement these systems, digesters are seen as, and I'm quoting here, one of the most cost-effective ways we have to cut these greenhouse gas emissions.
Cost-effective is good. But you mentioned dairies that can implement them. Are there limitations? Downsides?
Yeah, definitely important caveats. First, digesters primarily tackle methane from manure lagoons. They don't really address other emissions you get from dairy operations like ammonia or airborne particles, which impact local air quality. That's a separate issue.
Right, not a total solution for everything.
No. And building them is a major undertaking. You need permits, which can take time. It requires significant capital investment up front.
Big bucks.
Big bucks, yeah. And they need ongoing, long-term maintenance to keep working properly. As Francesca Hopkins herself cautioned, they're not for every farm. Size, location, finances, it all plays a role.
Makes sense. So it's a powerful tool, but not universally applicable, and it doesn't solve all the environmental issues associated with large dairies.
That's a fair summary. It's a targeted solution for a major problem, methane from manure, but within a larger context.
And looking ahead, how is the monitoring side of things evolving? You mentioned the research van. Are there other ways to keep tabs on methane?
Yes. California is actually working on expanding its monitoring using satellite technology now.
Satellites? From space?
Yeah, satellites that can detect large methane plumes from space. So if there's a big leak or a spike in emissions from a facility, like maybe a dairy or even oil and gas infrastructure.
The satellite sees it?
Potentially, yeah. It gives state regulators another tool. They can spot these large emission events and then follow up with the operators on the ground. Adds another layer of accountability and helps find problems faster.
That's fascinating, combining ground-level science with eyes in the sky.
It's all part of building a more comprehensive picture.
So as we kind of wrap this up, what's the big picture takeaway from this whole digester story, especially the research side?
I think Francesca Hopkins summed it up really well. She views this whole effort, the policy push, the science verifying it, the industry implementing it, as a potential model.
Right.
A model for how climate policy, science, and industry can actually align when the conditions are right.
Instead of fighting each other.
Exactly. You know, there's often so much division in the climate discussion, but she pointed to this as, quote, a real example of cooperation that leads to measurable results.
Cooperation leading to results. That feels like a good place to land.
It's a powerful example of partnership really making a difference on a tricky problem.
Okay, so just to recap for everyone listening, we've seen how these dairy digesters are taking a major source of methane decomposing manure and not just capturing it, but turning it into renewable energy.
And crucially, we now have solid, real-world data, thanks to that UC Riverside study, showing they can cut those methane emissions by around 80% when managed well.
And that managed well part is key, highlighting the importance of that collaboration. Science, the tech operators, the farmers, all working together, adapting and improving.
Absolutely. That adaptive management piece was critical to the success story.
So here's something to think about as you go about your day. We've just talked through this textbook case of adaptive management, right? Where a problem was spotted, solutions were tried, data was gathered, adjustments were made collaboratively, and, real results followed.
Think about how that model, that integrated approach, using science, policy, industry, maybe even community feedback, could serve as a blueprint. How might you apply that kind of thinking to other complex challenges, maybe environmental ones, maybe societal ones, perhaps even something in your own field or your own interests?
Yeah, what other kind of surprising sources of waste or emissions or just inefficiency out there might be solvable if we brought that same creative, cooperative, data-driven spirit to it? Definitely something to chew on. Thanks for diving deep with us today.